Well, welcome everybody. Really great to have you all here with us today. This is our last session of our ongoing USGS NIDIS listening sessions on drought prediction and water availability. Hope many of you have been with us along through the ride. Today is again the last session where we're going to do an overview and key takeaways of all the things we heard from you through the various sessions. My name is Marina Skumanich, and I'm at NIDIS with the National Coordinated Soil Moisture Monitoring Network, and also working with USGS on this project. And joining me today will be the full team, including Joel Lisenby with NIDIS, as well as Eric Smith, Stacy Archfield, John Hammond, and Catherine Dom from USGS. Next slide. Okay, so our agenda today, we are going to, I'm now doing the introductions, and then move into a report out. We're starting with, who did we hear from? We wanted to take a moment to characterize for you the range of participants that were a part of our 4 series of listening sessions, you know, where you come from, the kind of work you do, etc. Then we'll move into the meat of our report out, which are these questions 1 through 4. Those were the questions that we focused on during our breakout sessions for each of the sessions. Again, that's the meat of the whole event, where we had you all in small groups sharing with us your background, some of the things that you struggled with, and what your needs were. So starting out, we'll cover questions 1 through 3, which were the sort of framing context for our discussion. Number 1, how do you use hydrologic information for your drought and other kinds of work? Number 2, what are the challenges you face and uncertainties when you try to use that information? Number 3, what are the products you're currently using, products and services? And so that sort of set us up for then question number 4, what you need. With all of that background and context, what are your needs in the space of hydrologic drought information for prediction, monitoring, etc.? So we'll spend the bulk of this report out on that question. After that, we'll move to kind of the 30,000 foot level, where we talk about, from all of that, what are the key takeaways that we, both NIDIS and USGS, have from this series of sessions. And then finally, the main point, what are we going to do about it? How are we going to apply the information that you've shared with us to do a better job in serving your needs? It will end with some time for Q&A and discussion, where if there's something we missed saying or you didn't hear or you think is important, we'll be able to give you a chance to share that. Next slide. I'm having a pause. I'm not seeing oh, I'm sorry. That is the next slide. Okay, apologies. Yeah, so just to recap on what we did. I know not all of you went to all of the sessions, but these are the sessions we ran. We had our kickoff in February that kind of gave the framing for this whole series, then moved to streamflow, then groundwater, water use, and ecosystems, those 4 full-on listening sessions. And all of the webinar recaps from those sessions are available on drought.gov. There's the link there. Let's go to drought.gov/webinars and search on drought prediction, and that'll bring them all up. In addition, I will pop in the chat a web link that will take you to the first kickoff, and then from there you can navigate to the other webinar recaps. So we've got, again, full recordings of those sessions, as well as individual presentation recordings that you can go to if you want to have a sense of what we talked about. Next slide. Okay, sort of recognizing the fact that there have been questions raised about land acknowledgements and sort of that meaning, as we still wanted to take a moment to just say that we recognize the places that each of us calls home. Here in the United States is also the ancestral and, in many cases, enduring home of tribal and indigenous peoples, and that we seek to respect that history and work to learn from tribal cultures how to better care for the land. And we want to hold ourselves accountable for that and offer that statement in full respect and acknowledging the limitations of a statement like that. Next slide. All right, so now I'm going to pass off the moderating to Joel, my buddy Joel, and he'll cover who we heard from during these sessions.
Thank you, Marina. I'm Joel Lisenby. I'm a Drought Information Coordinator and Climatologist at NIDIS. I'm based in Boulder, Colorado. I've been working with USGS and this whole crew as we put together these listening sessions. And I'm going to go through the first little bit of what we heard. So first, who did we hear from? And then after that, I'll be going through questions 1 through 3. So who did we hear from? You may remember as you joined each of these different listening sessions, we had a few Mentimeter polls. And one of the Mentimeter polls was, where are you right now? And we had grouped things into these very general categories, sort of general regions around the country. And I took the information from those Mentimeter polls and threw them onto a map. You can see that most of the people who joined these listening sessions were from either the Southwest, the Intermountain West, or the Northeast. And we had a scattering of people around the rest of the country, including Hawaii, Alaska, which was one category, the US territories, which was another category, and then something that's not on this list. And looking at the email addresses of people who joined, we had most people from Canada, but we had one person from Greece, one person from Puerto Rico, a couple of other people around the world. But that gives you an idea of sort of geographically where people are joining from and who we heard from as we were trying to understand people's needs when it came to drought prediction. This was the output from another one of those Mentimeter polls of how do you use hydrologic prediction products? Most of you said that you regularly use them. A large majority said that sometimes you develop models or you generate or create products. And then fewer and fewer of you said, well, sometimes I use them or I don't use them, I rarely use them, or something else on this list. Another way to look at who we heard from in these listening sessions was, what sort of organizations do you represent? We didn't ask this explicitly within the listening sessions, but from the registration list, I was able to get a flavor of who was represented in those who registered and by extension, those who actually attended. A majority of those of you who attended these and shared your ideas came from federal government. You were federal government employees. At least you had a .gov email address, which did not include a state extension to it. So 338 government employees, of which I could sort out 127 were state employees, 215 were federal employees. You can see the breakdown there. I'm not going to read through all of these, but it was a pretty good mix of different ideas and perspectives that were represented here. And I think I was pretty happy with the diversity of opinions that came through. So that's who we heard from. Now, what did we hear? Marina went through the 4 questions that we asked in each of these different listening sessions. I took the input from each of the different listening sessions, and I put them together into one whole. And I'm going to go through each of those one at a time. This is just a quick breakdown of how we sorted all of the things that we heard. And later on in this meeting, Eric's going to go through this in a little bit more detail. So we had 4 different listening sessions, each of them focused on a different area of hydrologic prediction: groundwater, stream flow, water use, and water for ecological purposes. Each of these little squares, don't even squint, you can't even see it if you got even close, don't even try, but each of the different colors is a little post-it note of, and it's color-coded by the different breakout groups within each session. And they're also, you can't really see here, but they're grouped by each of the 4 questions. So within each of the broader categories, there were 4 different questions that we were able to get. And Eric's going to break down how we sorted these later. But for now, just get an idea that we heard a lot of things from a lot of different people. So the first question, how do you use this information? Now, I mentioned that there were 4 different sessions. So we had the groundwater information, we had the stream flow information, water use information, water and ecosystems information. And just to set our definition clearly, throughout the rest of my talk and probably throughout the rest of this whole meeting, I'm going to be using the term hydrologic information to encapsulate all 4 of those different listening sessions. So the question is, how do you use hydrologic information to anticipate changes related to drought conditions? Overall, we had 467 comments. And I sorted through them, and I was looking specifically for the comments that said, I use X to do Y, because those were very useful to know what information people use and what they use it for. And I found 19 of those, which were really helpful. And they all fell into 4 general categories: monitoring, prediction, permitting, and decision making. I'm not going to read all of these, but I'm going to give you a chance to just quickly read through them and I might hit on just a couple. Under the monitoring category, this is some of the things that we heard from you, and these are direct quotes from people who attended these listening sessions. I use time-lapse cameras to see water in springs and systems. I use weekly data to input into the US Drought Monitor. I use stream flow data at gauged basins to extrapolate into ungauged basins, and so forth. So that gives you an idea of the flavor of the things that we heard, and that was very useful. And thank you for those of you that shared with us the information about what information you use. Next up, it was in predicting. There were fewer of these. Somebody said, I use USGS data to produce seasonal temperature models. I use flow, precipitation, and groundwater data to understand future, I think I dropped a word off of that, but I think it was future conditions. Anyway, there were 4 here. You can have a look at those, and as I continue on to the next one. Under the permitting category, or the general category of what we heard, a lot of people use hydrologic information in their permitting processes to allocate water to senior users. Somebody says, I use surface runoff data for reporting and compliance. I use water use data to inform permit thresholds. Very sort of permit-driven or process-driven application of this hydrologic information. And finally, in actually making some decisions, here are 2 comments that we heard where one person said, I use storage and available water info to declare emergencies from drought protocols. So they're taking that hydrologic information and they're actually implementing it into a decision process. And finally, somebody uses hydrologic information to determine rangeland allotments. Moving on to question number 2. The second question is, based on your organization, what are the challenges, special considerations, or common uncertainties for predicting changes related to drought? And I would summarize this question with, what makes your job hard? All of us have a job to do, and sometimes that job is a little bit hard to do. So we asked, what's making your job hard when it comes to this hydrologic information? Overall, we had 443 comments of people answering question number 2 in the breakout sessions. And in this case, I'm not going to show direct quotes for this question because there were so many that were so related that I could clump them together into sort of overall themes. One thing that we heard loud and clear was that one of the things that made people's jobs hard was data. Not enough of it, insufficient temporal or spatial resolution, poor data quality, wrong or inconsistent data formats, difficulty accessing the right data, difficulty making observations in hard to get to places or with limited resources. So a lot of you said that not having the right data was something that was making your job very hard. The next one is uncertainty. It's similar to data, but sort of it's sort of applied broadly. There's too much uncertainty in the models or in the data that's available, and also uncertainty is difficult to communicate. The next thing that we heard from many comments about what makes people's jobs hard is permitting, policy, water rights legislation, and the general bureaucracy around getting water from one place to another. And the final, well, I don't know if this is the final, there's one more. So one of the other things that makes your job hard when it comes to hydrologic information is unaccounted for human interactions on water supply. For example, groundwater pumping, impacts on surface water, water reuse, unmetered or unreported withdrawals, etc. So there's a human component there where just not knowing that makes it difficult to do people's jobs. And this one is the final one, is climate change and large climate variability is making it hard to work within the given framework of hydrologic information, which that one makes a lot of sense, especially in places that do have very large climate variability of moving from drought to pluvial or the other way around, and just trying to anticipate those large swings in our climate. Next up is question number 3. What products or indices do you currently use to predict hydrologic changes in your region? Here again, instead of showing direct quotes, I looked through the the tools and indices and products that people use, and I counted how many times we heard people say those different things. And here's the list and even the count of how many times we heard people using the different tools and products and indices. Now, you may remember if you attended these listening sessions that in addition to this question, we also asked, what do you like or dislike about these tools? And here I am going to share just a few quotes, not all of them, but just to give a quick flavor of some of the things that we heard. So in terms of groundwater, somebody said, USGS groundwater recharge model needs accurate daily rainfall, evapotranspiration, land cover, and soil type. So there was something missing in the groundwater data that they were getting. Here's a positive comment. So ET or OpenET product is useful for irrigation application. So that's good to know. That's really good to know that how these products are being used and that it's useful. Stream gauge data, there could be more gauge data. I think we heard that quite a lot. Also, the data is useful, but only where that data is available. And there's a lot of gaps in the observation network. GRACE and NASA data is another one that we heard a few comments from. It has some of the things that people don't really like about it is that there's long data latency, coarse spatial resolution. GRACE and other NASA data can be challenging to understand. So thanks for those comments, those of you that brought those in. And finally, when it comes to USGS, NIDIS, and other government reports, there were two comments specifically about USGS reports. One is that they're not as helpful these days, which I assume means that they used to be more helpful than they are. And two is that USGS reports are outdated by the time of publication. So I shared those with my USGS counterparts first, and we talked a little bit about what that means, and they said it was fine for me to share that with all of you, that we did hear that. We heard that there's a lack of usefulness there. So that's my overview of questions 1 through 3. I'm now going to pass over to Eric to talk about what we heard for question 4. So take it away, Eric.
Thank you, Joel. I'm Eric Smith. I'm the Water Use Data and Research Program Coordinator for the USGS, and I'm based out of Austin, Texas. So as was discussed, we had breakout group questions that we asked during all 4 listening sessions. The last question was, what improvements in information and prediction would help you the most, with different flavors of that question depending on which session we were in, whether it was water use or groundwater. As Joel's discussed, we sorted the notes using Mural, with the sticky notes representing every individual comment, and then further classified all the notes into 4 different categories. Could you go to the next slide? Great. So as you see here, we have the 4 categories. The first category dealt with primary data production and collection, dealing with any comments that mentioned the need for improvements in on-the-ground information collection and monitoring. This category also covered any comments that mentioned a need for increasing the temporal or spatial resolution of the data collection. The second category here had to do with data access, so building on category 1 by improving the ways that the data collected can be accessed. The need for improved data tools and new delivery pathways was frequently brought up in all the different listening sessions. This category also included innovative ways to access and discover information through interactive portals, as an example. The third category you see here dealt with comments and suggestions that mentioned the need for any kind of analysis or assessments that can help everyone better understand the data collected, analyze data trends, improve and aid in decision-making, and assess the risks that we face going forward. And then finally, the last category, forecast, dealt with the need for improvements in tools, models, forecasts, and predictions. Anything that also dealt with uncertainty around forecasts and models was also classified as part of the forecast category. Next slide, please. Everything discussed on the last slide fits neatly into this pyramid here. I borrowed this pyramid concept from a colleague at the Texas Water Development Board and repurposed it with our categories stacked from the bottom up. The idea of this pyramid is to get us all to informed decision-making, which you see at the top, where boots on the ground and decision makers, planners, or anyone else that wants to use the available data and information can make informed decisions. Starting at the bottom, the base of our pyramid is the data production. Without data being collected all over the landscape, where would we be in better understanding what's happening out there, especially in these more uncertain times with prolonged droughts, extreme events, and just the general effects and perturbations related to our very complicated climate. Next up, data access. We've got to have a way to reach all the data that's been collected. And then the third tier above that, the analysis that needs to occur, includes all scientific studies, data analysis, examining trends, forecasts, and also the models. This third tier for analysis includes both the third and fourth categories that I discussed on the last slide. And then finally at the top, when we have built our stable pyramid, we can get to informed decisions. Next slide, please. Now that I've introduced you to the informed decision-making pyramid, let's take a deeper dive into the types of comments and suggestions we heard from all of you during the 4 listening sessions. Again, credit goes to all the great moderators and note takers that painstakingly captured the input we received from all of you. Now, as I discussed these, all the comments were important, but we did categorize the comments in order from the comments most often mentioned for question 4, and also going back to the big takeaways that we had from each of the sessions. For data production, one of the most common comments we heard was the need for improved spatial or temporal resolution. This could be anything from we need more stream gauges in our area to I would like a higher frequency of data collected for whatever type of parameter or data that you're looking for. To share a couple quotes we heard, we need quote, more long-term historic time series data with broader scale and higher resolution, unquote. Someone expressed the need for, quote, wall-to-wall soil moisture, unquote. We also had a couple comments with the need for more access in rural areas and a lack of data access for smaller towns and boroughs. Somewhat related to temporal resolution is the timing of the data. The seasonal component of data can be very important, particularly when dealing with heavy water usage and in times of drought. There are parts of the country, such as tourist areas, both along the coast and in the Sun Belt, that can experience heavy swings in water demand with tourist seasons. And then in parts of the country that experience freezing temperatures in the winter, there can be a lack of winter data given that it can be very difficult to acquire. So these things were all brought up. Next slide, please. Another big set of comments related to data production, related to just the types of data collected, with the most common requests related to soil moisture, stream gauges, groundwater, and water use. That's no surprise as this correlates to some of our theme sessions, but you all had some great comments and also requested more evapotranspiration data, water quality data, meteorological data, just to name a few. For soil moisture, it was requested the need for soil moisture at various depths, not just at one depth. And then as far as stream gauges, we need to have more spatial resolution for smaller streams, and then needing sensors of different types all located together so that you can kind of correlate the different types of data to make more informed decisions. Related to water use, more metered water use data would be useful, and for other types of records, the need for full lengths of record. I think this gets at the continuity of records and how important it is to have long records so we can see trends over time and even use longer records as a surrogate for seeing what will happen into the future. Next slide, please. Moving on to data access, a common theme was having more integrated access through a one-stop shop for all types of water-themed data, models, and forecast tools. I know individual agencies have their own portals. This theme pushed the idea of having different agencies have even more integration with one another. Here I have an example of a portal that integrates some Texas themed data across some different agencies where one could get historic info, weather, stream gauge, and real-time groundwater data in a one-stop shop. So I think more tools like this that cuts across different agencies would be seen as very beneficial. A few people mentioned having associated APIs so that it makes it easier for folks to pull their data into their own projects would also be useful. A few other comments about the lack of portals is that you need to have multiple, quote, multiple sources and web pages all open at the same time to figure anything out, unquote. A few people mentioned that USGS information can have some poor organization, and it's not always clear on what's available. In a theme similar to data access, there was a need expressed for a central hub to showcase hydrological models as well as more information on forecast products with the associated uncertainty. Next slide, please. The next theme around data access had more to do with communication, coordination, and training. Folks would like more about, quote, communicating info to non-scientists or impacts and risks to decision makers, unquote. There are multiple agencies communicating at any given time, particularly during droughts or other extreme events such as flooding, so dashboards that can integrate some of those communications would be seen as very useful. On the issue of droughts in particular, folks would like to see more interagency communication and collaboration and agreement on the best products for end users. Within the water management community, more coordination that incorporates multiple basins as well. The other two set of comments relate to better accessibility and better training. People need user-friendly websites for data, accessible long-term records, and even looking at designing websites to, quote, look at the end user first, unquote. For training, a lot of comments are made related to more training around the available tools and just broadly making people aware of what tools currently exist. Next slide, please. Our third category, analysis/assessments, had a wide range of different topics and comments, but there were some major themes. Groundwater surface water interactions and the topic of base flow came up multiple times, not only in the groundwater session, but also frequently in the ecosystem session and even the water use session. I know the groundwater surface water interactions has been a very popular theme, percolating for some time. And then there was the very nice USGS circular published by Tom Winter and others that really pushed the idea going on 25 years ago now. Particularly now, as we enter, as we enter longer and more prolonged droughts, the relevance of this connection is more important than ever. Next, we had a lot of needs expressed about better understanding water use, a topic near and dear to me. Without a clear understanding of water use, it can be difficult for everyone out there dealing with water planning to have a good sense of how changes in water use further complicates planning during droughts. Next slide, please. Somewhat connected to the water use topic, the ties to water availability came up during the ecosystem sessions, as there can often be conflicting water needs with minimum flows required to maintain healthy ecosystems while providing water for all the societal demands and functions. It was pointed out that, quote, drought restrictions for ecosystem services have socioeconomic consequences, unquote, and that we need, quote, more ecosystem science tied to flow to determine needs, unquote. In general, we need better social and economic impact analysis for drought. Aside from drought, we also have other extreme events that occur with more frequent storms and the potential for more destructive hurricanes, as we just recently saw in Florida. Next slide. On the water planning side, we need a better understanding on the effects on water planning. Some noted that they would like to identify practical triggers for municipal water suppliers and more knowledge on how to manage emergency levels properly. For those responsible for making decisions, from water planners and state water agencies to one city council member that was in one of my groups, we need to, quote, identify products stakeholders need, unquote. We also need better education and collaboration to ensure the right data is being used to answer the questions around water planning. Some noted that the drought monitor is not necessarily the best way to devise drought plans, and while finding the drought monitor very useful, some decisions have to be made locally at small scales, so they need more guidance for their area. Next slide. Finally, our last part of the analysis that was in the third tier of their pyramid, along with the assessments, was forecasts and models. There was strong demand for predictions, models, and forecasts of all types, recognizing many already exist, but the need particularly for areas that might not have as much data collection. We already have ensemble climate data, which combines several models, so folks would like to see more done with ensemble stream flow forecasts. Also pushing the drought monitor farther in time, Then the current drought monitor was also brought up a couple times. It was also mentioned that it would be useful, if possible, to have projections for areas with highly regulated flows. Next, there was a discussion about the frequency of forecasts and models, so similar to comments that we heard for the data production. Seasonal stream flow outlook would be very helpful, particularly for low flow forecasts, which would relate to periods of drought, and also further out if possible for the current National Weather Service ensemble. Next slide. With all the forecasts and models comes uncertainty, and many folks mentioned that they would like to see more around forecast uncertainty and having acceptable confidence levels for translating to actionable decisions. There needs to be more caveats with using models and better communication of forecasts and model uncertainty to decision makers that might be relying on them. Finally, a common theme across all the sessions, as you heard me say a couple times already, there needs to be more coordination and communication. Better communication around drought products and communication on just what all the different drought types are and what that means for a particular area. Next slide, please.
Great. I'm going to take over from Eric now. I want to start by saying thank you, Eric, for that very detailed and rich review of the needs we heard from everyone. And in case that was a little overwhelming to you, just want to point out that we are going to be documenting this in a write-up that we'll be attaching to the webinar recap webpage. So you don't have to keep everything in your head. We will have that available, documented. So now we're going to shift to the last part. So that, again, the 30,000 foot level. After hearing all the things that we just went over, that you've heard, how are we, NIDIS and USGS, looking at this at the highest level? What are the key takeaways for us that we'll carry forward? So we're going to cover several sections. First of all, what are the things we heard that we expected? What are things that were key takeaways but didn't particularly surprise us? Then we'll move to, well, what were our aha moments? What are the things we heard that did surprise us, that were really unusual and really helped giving us some food for thought? And then from that, go to, again, next steps. What are we going to do with this information we've got? So this is going to be another sort of group effort here. So I'm going to invite Joel, Stacy, and John to turn on their cameras, and we'll talk through our different key takeaways. Next slide. All right, so what came as we expected? What are the things that were not particularly surprises, but still really important takeaways? Number one, there is a lot of interest in better water availability information. Again, this didn't surprise us, but it's just really important to note. We hear the interest you all have and the need you all have, and we're really glad that we have this opportunity to try to move forward on some solutions for you. John?
Thanks, Marina. Yeah, and in addition to that information, we saw kind of as we expected through this listening session that, this is a really diverse user community that has a lot of different needs. And so there's no one size fits all solution that will work for everybody. So we need to kind of investigate, a number of different alternative tools and data sets in order to supply information for everyone. And I'll pass it on to Joel.
So one of the other things that we heard that we kind of expected was you reminded us to put the perspective of the end user first, which makes a lot of sense and is sort of the way that we all should be doing business and creating new things anyway. Over to you, Stacy.
Yep, and then lastly, with the end user perspective in mind, we understand that there's always more to do in terms of making data and information easier to use. The data that we collect needs to always be ensured that it's accessible for everyone to make use of it as they need to.
All right, our aha moments. So we expected that we would hear from you that each of you wanted a certain specific tool or product, and you had a very specific need that you wanted us to address. But what we learned was that you want innovations all along the data pipeline. Yes, you may want some specific products, but also you want more data. You want easier access to data. You want more and different tools. You want more navigation of existing tools and information. and you want more help interpreting and putting that data to use. So again, an aha for us and a really important takeaway. John?
Great. Yeah, thanks, Marina. And another expectation that we had was that, a lot of these focuses for improvements would be strictly for prediction. That's where we were thinking a lot of the feedback would come. But what we learned was there's still a lot of need for observations and additional monitoring, whether that's in soil moisture, groundwater, stream flow, monitoring of ecosystem response, et cetera. And these weren't things that we were necessarily expecting to hear. So thank you very much for providing that feedback, and I'll pass it on to Joel.
Thanks, John. So the next thing that we expected to hear was that you wanted directly applicable info. So similar to what I said a few minutes ago was I thought you were going to say, I want X to do Y. But actually what we heard, a lot of you want to really better understand the overall natural system, the nuances of the water cycle. You want to really understand the why behind the data that you use and the processes that are in place. That was quite insightful for us. Stacy.
Yeah, thanks. And then lastly, this insight really goes credit to Catherine Dahm from the USGS Rocky Mountain region. Was really the expectation was that you came to share your thoughts with us, but really what we also observed was that you came to learn and to also hear from what others had to say as well. And from that, we were able to take in additional valuable insights and thoughts from that perspective. So I think we go back to Marina next. Thank you.
Actually, we're going to let Joel start this next slide.
Joel, thanks.
Okay, so this next slide is focused just on NIDIS and how we're going to apply this information. And the first thing that we're going to do is to frame, we're going to use this information to frame future drought early warning system activities. So our strategic planning, my stakeholder engagement within the region that I manage, this information is going to provide a nice framework for that. Marina, number 2.
So the other thing we're going to do is take what we've heard from you and use it to help us focus future NIDIS grant competitions. We know we need to advance our understanding in some areas to really make a difference here. And so here are a couple of examples. There were more that came out, but these are 2 pretty prominent ones. As people actually have already mentioned, the groundwater surface water interactions during drought. Can we get a better handle on that? And I think we actually heard people say, and I would add, perhaps also including the soil moisture component of that. So again, water cycle. Let's get a sense of those interactions so we can apply that to applications and user needs. Number 2. Water use changes under drought in different regions. A theme that NIDIS has known, but it never hurts to keep hearing it, is the importance of tailoring our information to different regions. So what are the water use changes in place A versus place B? Let's get a little better handle on that. Joel?
Thanks, Marina. So one of the other ways that we're going to apply this information within NIDIS is going to guide future interactions with how we work with USGS. We worked on this project together to hear your input together, and going forward, I think that there are a few projects that NIDIS and USGS can continue to work on together. This includes improved communication tools and also improved data accessibility. Now, exactly how we do that is still to be figured out, but that's definitely one of the takeaways and next steps from what we heard. And you want to wrap this up from this slide, Marina?
Yeah, the last thing, just honoring the mission of NIDIS, which is to be this collector partner across federal agencies, bringing people together on drought issues. We want to make sure we take this information as we collaborate with other federal agencies to meet your hydrologic information needs. So that's definitely last but not least on our list. Now,
Great.
USGS. Yeah, go ahead.
And then in previous sessions, we had described some of the USGS drought program work that we had been doing. There's 2 projects, one that I lead and then one that John Hammond will discuss in the next slide. And from the input that we've received from you and also in our internal thinking about the drought projects that we're working on, we've been thinking about refocusing one of the projects, the project that I'm about to describe, on looking at some of the aspects of drought risk from assessing societal, ecological, and water use sector vulnerability to drought. And so I wanted to take a minute just to describe that because it's relevant to some of the stakeholder input that we've received from this session. So what we're looking to do as we refocus some of our efforts in this project is to inform interactive national mapping products that we have planned already in the water resources mission area of the USGS to provide information about drought risk for water resources by considering some of the factors, including socioeconomic effects on drought risk, the ecological constraints and effect on drought risk, and then the effects of water planning and water use sectors on drought risk. So really trying to bring together not just the climatological aspects of how drought might affect surface water and groundwater resources, but then how that drought might be further affected by things like socioeconomic effects, water use, water planning, and then how drought risk might be exacerbated or affected, I should say, by placing additional ecological constraints on the water resources of the United States. So, and then John will describe the next project that we have going on at the USGS related to drought.
Perfect, thanks, Stacy. And yeah, just to reiterate, Stacy's comments, we're using some of the feedback that we've received through these listening sessions in order to kind of refocus and to enhance some of our existing efforts. And so I'll be describing our takeaways relevant to the data-driven drought prediction project. So this is prediction focused, and there were 5 key takeaways. And this comes from looking at all of those comments that Eric summarized earlier in today's session on improvements to information delivery and prediction. And so these 5 broke down to increased coordination, quantifying uncertainty, forecasting needs, data needs, and the different types of inputs we use for our models and the processes that we're able to capture. So, through ongoing engagement with NIDIS, as well as other federal partners, we are targeting to improve our within agency and interagency project coordination. We are, specifically embarking on efforts to quantify the uncertainty of the predictions that we are making. And that's to provide the range of uncertainty around the predictions, as well as to optimize our models in order to reduce the uncertainty ranges. We've heard, a variety of different forecasting needs from those that have participated in these sessions, and those have ranged from short-term predictions, on the daily to weekly timescales, as well as, needing information at the seasonal scale as well. And we're also really focused on not only stream flow, but quantifying and predicting drought within groundwater component as well. We did hear about additional data needs, and so not just forecasting looking forward, but also being able to provide historical and real-time estimates of drought properties. And also the need for these predictions to be fine scale, so getting down to be relevant to local communities, but also having broad coverage, so spanning across regions and ultimately nationally. And then finally, on this topic of model inputs and processes, we've heard, we want to be using models that are quantifying and utilizing relationships between groundwater and surface water. We want to be using data that's quantifying, the various ways that humans use water, and also being able to predict in areas that have substantial human flow regulations. Is, that's the majority of the areas that we're working in. So I'll leave it there, and then I think we're now going to transition after this slide into a question and answer session. Where we're going to be inviting you to post your questions in the questions tab of the GoToWebinar. And we're going to do our best job to answer as many of those questions as we can during the remaining time in the session today. But there will also be a compilations of questions and answers that will be released with the meeting recording that'll follow in the weeks after this event. Marina, anything else to add?
Yeah, just want to invite people, if you don't have a question but have a comment, please do share. We'd love to hear. Here's another little listening session moment where you can share what you just heard, what surprised you, or what we missed, etc. And we'll be able to share that with the group. So in this format, you will have to do it via that question box. but would look forward to your comments as well as questions for us.
And so we'll take another minute or so to allow people to enter their questions into that question bar, and we'll let a few more questions come in, and then we'll get going on answering some of these.
Mm-hmm.
So thank you all for your continued participation here. All right, and we're seeing a lot of questions come in. Go ahead, Stacy, sorry.
Yeah, so it looks like I think I see one question coming in, John, that this might be for you if I can ask you. So one question is, how does the USGS Drought Prediction Project relate to the USGS National Water Center water model efforts? Oh, I'm sorry, not USGS, but the National Water Center water model efforts. I'm sorry, I misread that. Yeah. Yeah,
and that's an excellent question. Thank you to Meredith for asking that. So, this effort that we're, embarking on at USGS uses data-driven models. So these differ from the physically based models. The models like the National Water Model and the National Hydrologic Model. So these are, kind of different tools that can be used for making predictions. And, we are in communication with these groups to basically learn, what kind of success have they had in the past, where have their models struggled. And so we're learning from those experiences and also evaluating all of our models in the same way. So we use the same criteria and can see where one model is potentially better than another for specific elements of the flow regime. And so, our effort is definitely not in a vacuum. We're in communication with some of the local river forecast centers as well to produce prediction tools that are complementary to other existing projects. So yeah, thank you very much for that question.
John, I'll put you on the hot seat one more time and then we'll shift gears. But do you have, could you speak a little bit more to the prediction work and do you suggest any specific hydrologic model that would be best for drought predictions? Or could you talk a little bit more then about maybe the models that you're using for your prediction work?
Sure, yeah, thank you very much for that question, Stacy. And I'll first say that, the selection of a model is very much going to depend on, your very focused needs for that model. And so if you're looking for something like a seasonal outlook, there are existing tools from the river forecast centers or from the National Hydrologic Model that can provide you with those estimates of, say, seasonal water supply. Also, the NRCS water supply forecast can provide that information. The models that we're working on currently, these data-driven models, are trying to improve the accuracy and also the lead time. So can we anticipate a hydrological drought, whether that's in stream flow or groundwater, longer in advance than we're currently able to? And we don't have the firm answers to that question yet, but we're hoping that because of the success that's been shown in using these machine learning models for predicting other hydrologic extremes, and their ability to ingest really large amounts of information that might be able to identify patterns that we weren't able to see with other techniques, that these strategies might give us this extra capacity for early warning. Thanks,
Great.
Stacey.
Thank you. And then you probably saw in the chat, the next question I'm going to ask next is, someone saw that the more monitoring, the better monitoring is a must for most. That was one of the comments that we had pulled out. What does the committee think is the biggest limitation to achieving this?
I'll start and answer. I think we need to keep hearing from you all about the importance of this because, and in fact, your Congress people do as well, because while there's attention to a lot of high technology stuff, we could use more support for the on the ground, straightforward monitoring systems that are really the foundation for a lot of our understanding of the world. I think that's something that is broadly recognized sort of by the public, how important it is to have a sense of what's going on in my backyard, and also obviously all the interest people have in tracking environmental conditions, but it needs to translate into direct action on the agency level to really invest in those resources.
And
Thanks,
I can take
Marina. Oh, go ahead.
Oh, go ahead. You can go ahead. Oh, okay. Yeah, I mean, kind of building on what Marina just said, I think that funding can be definitely a challenge for long-term, stream gauges or any other types of data collection. Also, a lot of times, data being collected might be for a specific study, so it has a finite amount of time that the data is being collected, and you get to the end of that, and you're like, well, gee, wouldn't it be nice if we could just keep this going? And then there's not a mechanism to keep that funding going for monitoring. We also need to find a way to better vet citizen collected data. I mean, I know there's a lot of people out there willing to collect the data, but we just have to find ways to QA that data and ingest it into databases so that it can go out to the broad public. So that's another thing that commonly comes up, and we really have to do a better job of making sure that we can get climate science data out there, or climate, just any type of data collected by citizens. So I'll say that.
Marina, did you have a follow-up?
Just one addition. I just want to put a plug in for the USGS NGWAS, Next Generation Water Observing Systems, which I think are sort of localized projects at this point, but really doing some of that integrated water monitoring systems together, starting out Chesapeake Bay. One of you all will know better than I, now moving to the upper Colorado, I believe. But yeah, so I think that's another point here, is I think the agencies are recognizing we can do better, smarter, integrated monitoring that will hit a number of things at the same time. So that's exciting. But again, we need more of that. And certainly more soil moisture monitoring.
Perfect. Thanks, Marina. We have another question coming in, and this one's from Scott. Scott's interested in the relationships between drought interactions, water shortages, and increases in wildfire frequency. So, Stacey, could you talk about some of the work on your ongoing project that relates to these different hazards and the relationships between them?
Yes, so we do have some work going on looking at the relationship between wildfire and drought, and the what types of feedbacks might be occurring there. So I just wanted to mention we have research in the works that should be completed in FY23. This is using what's called a panel regression approach from econometrics literature, which is essentially a more complicated regression-based approach where you're looking at wildfire areas and using them to look at particular drought metrics to try to understand what the explanatory power of wildfires might have, or burned areas might have, on predicting particular drought metrics. And you'd use this more sophisticated regression approach because it better estimates like the ability of that regression equation to eliminate mathematical complications that come up in more basic regression approaches. So, but the hope is that that's one way that you might be able to isolate the effects of looking at wildfires on drought. So we might be able to make statements from that say, for a 2%, 1% increase in burned area from a wildfire, we might see a 3% increase in this particular low flow statistic. So we might be able to make some connection then between increase in burned area and say something like an increase in this drought metric, or decrease in this drought metric. Maybe we find some relationship where we might find that there's some change in the runoff relationship that might maybe not be possible, but that's the type of way we're trying to get at this question right now in this statistical approach. So hopefully that answers that question. I think there were probably maybe some process-based approaches, but that's how we're trying to get at it at this first order approach. So thanks. It's a great question though.
And if I could just mention, NIDIS is also engaged, as well as other agencies, of course, U.S. Forest Service, in this whole question and how to better get a handle on the other side of it, which is what about water shortages or water states can help better inform risks of wildfire. And again, if I may toot my organization's, my program's own horn, we're looking into soil moisture and how that could be an important indicator of wildfire risk, both in forested as well as grassland areas. So we look on drought.gov, you'll see some information about that. But we're not the only ones. It's really on a lot of people's mind right now, that interplay. And of course, climate change is the fourth thing to add there.
Perfect. Thank you very much to you both for answers to that question. Our next question that's coming in, so in your upcoming report about the listening sessions, do you anticipate adding information about the relative number of responses that you received for a specific type of input, or otherwise somehow prioritizing efforts to understand the relative importance of the various groupings? The person who posed this question, asked this because, they recognize that we got feedback from several hundred participants. So,
yeah, I can take that. So I think the short answer is yes, but we don't know if that's going to apply across the board. There still is more work to understand all of the information that we heard and how to sort it all out. And we were focusing on getting ready for today's presentation, and the next step is to then look at how we're going to frame that in the report. I think there's a few different ways we can approach that. One is to think, well, almost democratically, of where there were more comments, that comment carries more weight. But there's also another way to think about that, is just because more people said the same thing, is that really where the greatest value is going to be created in future projects? And so we wanted to look very carefully about why the why behind the comment. Why did somebody say that? What do they really need? What's the problem they're trying to solve? And where is that going to apply most into the work that they do? So I mean, that's my take on it. There's still a lot of work to do in formulating that final report, but I think generally the things that we heard the most, they come out very loud and clear. So that'll frame things. I don't know if Eric wants to add anything to that.
I think you said it very well. I mean, there are definitely metrics that we could come up with that would kind of get at what the person asked the question about, but we just have to make sure they're useful to everybody, not just metrics for the sake of metrics, but something that's going to be useful for the audience to get at what Joel's just talking about. So yeah, great question though.
Okay, and that has to be our last question. We've got several more, and apologies for not getting to them right now, but as we mentioned, we'll be documenting those and then providing answers on the web page, with also the web recap recording for you. So just very quickly at the end here, wanted to take a moment to once again say our deepest thanks for the time that you've given us to help us understand better needs out there and better ways we can improve our products and services to help have better outcomes in terms of drought. Thanks again for all your help there, and thanks to my panelists. We've had a great team, and we're going to carry this forward. We are going to do a final report that is not going to be a lot of words, but we'll again document some of the findings that we have that we can share with you all, and then again other agencies. Anything else to share, you guys, before we say goodbye?
Just a very quick thank you to those who were not on this panel, and that would be Brian Clark and Catherine Dahm, who, well, they did a lot of the work to get us to this point, and so big thanks to them.
Yeah. All right. Again, thank you very much, everybody, and hope we'll see you around. Bye-bye.